Welcome, my dear students in Prep 3. Let's continue our algebra lessons. Our lesson today is relation and function. What do we mean by relation? Here we have the definition of relation. The relation is, if you have two sets x and y, for example, the relation from set x to set y is a connection. So we will connect some or all elements in x with some or all elements of y. We denote it by or. The relation or from x to y is a set of ordered pairs, okay? So you notice that it is like the Cartesian product. Also, the first projection belongs to x, which is the first set, and the second projection belongs to y, which is the second set. So it's very, very similar to the Cartesian product. Actually, it's a subset of the Cartesian product, because in Cartesian product we take all elements of y with all elements of all elements of x with all elements of y. But here, all or some of them. So the relation is a subset of the Cartesian product of the two sets. Okay, also like the Cartesian product, the relation can be represented graphically by an arrow diagram or Cartesian diagram. Let's start with this exercise. If you have two sets x and y, set x is 1, 2, and 3, y 3, 4, 5, and 6. R is a relation from x to y. So the first projection should be from x, the second projection should be from y. Where A related to B means A plus B equals 6. So if we have an ordered pairs A and B, A belongs to x and B belongs to y, they can be written in this relation if the summation of A and B equals 6. Okay, and of course I'll take A from x and B from y. Okay, the required here is to state the relation. This is the first required, state the relation. What do you mean by state the relation? Write it as a set of ordered pairs. The second required is represented by arrow diagram. So we will write the set of ordered pairs and then represent using arrow diagram this relation. Okay, I want A plus B equals 6. I'll start from x. I'll take 1. 1 plus what from y equals 6? 1 plus 5. So the first ordered pair is 1 and 5. Okay, then I'll take 2. 2 plus 4 equals 6. Then 3 plus 3. So now we have 3 ordered pairs, 1 and 5, 2 and 4, 3 and 3. Why? Because the summation of the two projection in each order pair equals 6. So the relation is 1 and 5, 2 and 4, 3 and 3. Now I want to represent this relation by an arrow diagram by the same way as Cartesian product. This is the arrow diagram. X consists of 1, 2, 3. Y, 5, we have 3, 4, 5, and 6. Then I'll draw arrows from 1 to 5, from 2 to 4, and from 3 to 3. Okay, another exercise. If x 1, 2, and 4 and R is a relation on x. What do you mean by relation on x? Where is y? There is no y. This is a relation from x to x. A relation on x, it means from x to x. Where A related to B means A twice B. A should be twice B. Okay, for every A and B belongs to x. Okay, let's start. I want to state the relation and represent by arrow diagram and also Cartesian diagram. Let's begin. 1 with what? I want 1 to be twice B. So, yes, there is no number. 1 is not a twice of 1 or 2 or 4. Okay, let's move to 2. 2 is twice of 1, so I'll take 2 with 1. Finally 4. 4 is twice 2, so I'll take 4 with 2. So I have 2 elements, 2 and 1, 4 and 2. Let's draw x and x. 1, 2, 4. 1, 2, 4. 2 with 1 and 4 with 2. Okay. By the same way, I'll draw the Cartesian diagram. Horizontal and vertical. I'll write the elements of x. Then we have 2 with 1. This is the point of 2 and 1, and 4 with 2. So this is the Cartesian diagram. And the relation has a rule. The rule is, I can use this rule to determine if an element will be related to another element or connected to another element in Y or not, according to the rule. Okay. Also, we have a function or mapping. Any relation can be considered as a function if we have some conditions. Okay, the condition is that if each element in this set connected only with one element of the second set. Okay, so the first set has an element. Each element of the first set connected with only one element on the second set. So if you write here, if you write R as a set, if you write R as a set, then each element of X appears only once. Sorry. So each element appears only once as a first projection. Also, each element, if you draw the arrow diagram, each element of X has one and only one arrow going out of this element to one element of Y. Okay, so each element has only one arrow goes to Y. If you draw a Cartesian diagram, so at the vertical, each vertical line has one and only one point. This is the condition. If this condition is satisfied, I can say that this relation is a function. Okay, let's clarify this point using examples. But before, I want to say that X, or the first set, is called a domain. The second set is called codomain, and also we have a range. A range is the elements in Y which related to elements in X. So the range is a subset of the codomain. Okay, look at here. This is an exercise. Which of the following relations represent a function from X to Y? And if the relation represents a function, find the function range. The first one, I have a condition. Here we have an arrow diagram. So each element in X has only one arrow goes to Y. The first one, 1 has one arrow, 2, one arrow, 3, one arrow. So R1 is a function. The range, I'll take the range from Y, from the second set. The elements which receive, any element receive an arrow is in the range. Okay, so 1 belongs to the range and 9, 1 and 9 only. Okay, R2, I have one arrow and only one arrow from 1 and from 2 and from 3. So this is also a function. Where is the range? The range from Y, 1, 4 and 9. Let's move to R3. Is R3 a function? No, because here 1 has 2 arrows. 2 arrows goes from 1 to y. So this is not a function. R3 is not a function. What about R4? R4 I have 1, 2, 3. There is an arrow from 1 to 1 and from 3 to 9. But there is no arrow here from 2. So this is also not a function. So R4 is not a function. Okay? By the same way, if you have the Cartesian diagram, look at the vertical lines. Each line should contain one and only one point. Here, for example, 1 point, 1 point, 1 point, 1 point, and 1 point. So this is a function. The range from y, 3 and 4, 6, 8, 9. Okay, so number 1 is a function and the range is 3, 4, 6, 8, and 9. T2. Let's see, here we have the first line, the first vertical line has 2 points. So this is not a function. Number 3. Each vertical line has only 1 point. So this is a function. The range is from y here only 3. 3 is the range. Okay? So this is the functions. So number 1 and number 3 are functions. Number 2 is not a function because here we have more than 1 points on this vertical line. Let's continue. Let's take one more example. If you have two sets x and y, x consists of 1, 2, 3, y 1, 4, 6, and 9. And R is a relation from x to y where a related to b means a equals root b. This is the rule of the relation. Each relation has a rule. This is the rule of this relation. A equals root b. Okay. Write the relation and represented by arrow diagram. Okay. Let's see. We want to write the relation. It means to write the set of ordered pairs. This is the rule. It's very important. A equals root b. So if I choose 1, 1 equals root what? Root 1. So I'll take 1 with 1. Why? Because 1 equals root 1. 2 equals root, yes, root 4. So 2 with 4. 3 equals root 9. So now I have 3 points. 1 and 1, 2 and 4, 3 and 9. Why? Because 1 equals root 1, 2 equals root 4, and 3 equals root 9. I can draw this relation by an arrow diagram. It's very easy. 1 with 1, 2 with 4, and 3 with 9. Okay? So this is the arrow diagram. Mention giving reasons if R is a function from x to y or not, and if it is a function, mention its range. Okay. Is R a function? Yes, of course, yes, because each element here, we have for each element only one arrow goes from this element to y. So R is a function from x to y because for each element of x there is one and only one. Don't forget, only one arrow goes to an element in y. Okay, what is the range? The range, the numbers here or the elements receives arrows 1, 4, and 9. Okay, that's all about our session today. I hope you have understand. We will continue next session. We will talk about the symbolic representation of the function, and also we will learn how to determine if the function is a polynomial or not. Okay, so we will talk about polynomial functions and the symbolic representation of the function. Thank you very much for watching. See you next session and goodbye.